When you're dividing rational expressions, it works the same way as multiplying rationals. So when we are dividing by a fraction, it's the same thing as multiplying by the reciprocal. So what we're going to do is we're going to just reset up the problem. So we have x squared plus 5x plus 4 over x squared plus x minus 12. So we're going to keep that. We're going to change the sign from division to multiplication, and then we're going to flip the second fraction. So 2x squared minus 6x over x squared minus 1. So keep, change, flip. So keep the first, change the sign, flip the second. Once we have this set up, then it's like a regular multiplication problem that we did previously. So we're going to factor everything. So the first numerator we need to factor, so we need to come up with numbers that multiply to 4 and add to 5. So we're going to use 4 and 1. So x plus 4 and x plus 1. On that denominator, multiplies to negative 12, adds to negative 1. So we're going to use x plus 4 and x minus 3. We're going to take out the GCF of the next numerator, so we could take out a 2x, and we're left with x minus 3. And then the denominator is difference of squares, so we have x plus 1 and x minus 1. So same rules apply. We're going to cancel out things that are on opposite levels. So the x plus 4 we can cancel out with this x plus 4. The x plus 1 here we can cancel out with the x plus 1 here. And the x minus 3 we can cancel out with that one. So what we're left with is a 2x on top and an x minus 1 on the bottom. So that is simplified form. The thing that's slightly different about the domain restrictions here is that you need to have a domain restriction on anything that is a denominator or that once was a denominator. So since the first fraction we kept the same, we're just going to take the denominators and set them to 0. So x cannot equal negative 4, and we'll take x minus 3, so x cannot equal 3. Now, we need to take both the numerator and the denominator from the second fraction. So originally, our denominator was 2x squared minus 6x in the original problem. But then we switched it, and that became the denominator, x squared minus 1. So both of them at one point were in the denominator. So we have to take both of them and set them equal to 0. So the original denominator was, once we factored it, 2x and x minus 3. So we're going to take that 2x and we're going to set that to 0. So this 2x here is going to become x is not equal to 0. The x minus 3 is the same x cannot equal 3 as we already have, so we don't need that. So now we're going to take x plus 1, so x cannot equal negative 1, and then we'll take x minus 1, x cannot equal positive 1. So when you have division, you have to make sure that you take the denominator of the first fraction and then both the numerator and denominator of the second fraction. So if we look at these examples, now the first one, you don't have to factor anything, but we always want to do our keep, change, flip first. So we're going to keep the 7x, we're going to keep the 4y cubed, we're going to change the sign to multiplication, and now we're going to flip the second fraction. So 8y over 21x cubed. Now we're just going to reduce. So I can cancel out this 7 becomes a 1, this 21 becomes a 3. This x is going to become a 1 and go away. This x cubed is going to become an x squared. The 4 is going to become a 1. The 8 is going to become a 2. This y is going to be gone and become a 1. This y cubed is going to become y squared. So what we really have now is we have 1 over y cubed times 2 over 3x squared. So this is going to be 2 over 3x squared y cubed. And that's simplest form. We have to take all of our denominators. So we're going to take the 4y cubed and set that to 0. So y cannot equal 0. We're going to take the 8y. Again, that's going to be y is not equal to 0. So we don't need to write that twice. And then we have to take the 21x cubed. So that's going to end up being x cannot equal 0. Okay, in the second one, we're going to keep the first fraction, and what I'm going to do is just change the denominator so it's written a little bit nicer. So I'm going to change it to negative x plus y. So I haven't changed the value of it, it's still exactly the same. All I'm doing is switching the way that it's written. We're going to change the sign to multiplication, and then we're going to flip the second fraction. So 5x minus 5y over 18. Okay, so from here we're going to factor. So the first numerator, I can factor out that 6, and I have x plus y. In the denominator, I'm going to take out a negative, so I have x minus y. The next numerator, I'm going to take out the GCF of 5, so I have x minus y. And then the bottom is just 18. So what I can do now is cancel out the x minus y's, and then the 6 I can cancel out, and I can change that 18 to a 3. So what we have now is a 5, x plus y on the top, and on the bottom we have a negative 3. So we can leave it, or you can distribute the 5. So we're going to take our denominators, which would be x minus y, because once we factored it, it became x minus y. The 18, that's the denominator, you can't set that to 0, so any constant is not going to have a restriction. You'll only have a restriction when you have a variable. So if I set x minus y equal to 0, I get that x cannot equal y. So that would be my restriction. Okay, for the last one, again, we're going to keep change flip. So keep the first fraction. We're going to change that sign to multiplication, and then we're going to flip our second fraction. Okay, from here we're going to factor. So we have x squared on the top. And now the denominator, we're going to factor, so what multiplies to 1, that adds to 2. We're going to have x plus 1 and x plus 1. X squared minus 1, which is our second numerator, we're going to use difference of squares. So x plus 1, x minus 1. And then the 3x we're just going to keep. So now when we go to cancel, we can cancel out this x plus 1 with one of the x plus 1s. We can't cancel both of the x plus 1s. The x squared, I can take away one of the x's and cancel out the x in the denominator. So what we're left with is x minus 1, and on the bottom we have a 3x plus 1. So we can leave that as our answer, or we can distribute it either one. So now we're going to take all of our denominators, and we're going to set them to 0. So the first denominator on that first fraction, we have x plus 1 and x plus 1. So they're both the same. If I set them to 0, I get x cannot equal negative 1. The original denominator was x squared minus 1, which factored to be x plus 1 and x minus 1. So if I set x plus 1 to 0, I get negative 1, which I already have. X minus 1 equals 0 is going to give me x can't be positive 1. And then 3x is the new denominator. So if I set that to 0, x cannot equal 0.